Hello, hi to all my Form 4 students. Today we are here to continue on the chapter Acid, Bases and Salts. We are going to do part 5 from this chapter, and the pages that I am going to discuss today is from page 113 to 115 from this module. Okay, so let's start. So the subtopic that we are going to discuss today is called standard solution. Okay, so in our part 4 video, teacher taught you on how to calculate the concentration either in gram per dm cube or mole per dm cube. So these are the two units for you to calculate concentration. So the concepts and the knowledge to calculate concentration will come in handy when you are going to prepare standard solution. Now, let's go to the meaning of standard solution. So, standard solution is a solution where the concentration of the solution is accurately known. Okay, so if you are just mixing water with just a syrup to make orange juice or anything, syrup, okay, just a syrup of the orange, you just mix, that is not a standard solution because you don't know what is the concentration of the solute, or maybe the mass of the solute you're not very sure. So that is not a standard solution. But a standard solution is a solution where the concentration is known. For instance, when I say 100 cm cube 1.0 mole per dm cube, this is standard solution. Why? Because the concentration is accurately known. If you look at here, 100 cm cube 0.2 mole, this is standard solution. Okay, so this is an example of standard solution where in fact the volume also known and also the concentration is also accurately known. Okay, so now let's go to the meaning is solution where concentration is accurately known. Okay, so you know the concentration accurately. For instance, 0.5 mole per dm cube of sulfuric acid, 1 mole per dm cube of nitric acid or copper 2 sulfate or anything, but as long as you know the concentration. Now I am going to show you, and also together with the calculation we are going to see how to prepare example of one standard solution. Okay, so please keep in mind that your video part 4, okay, teacher's video part 4 will come in handy when you are doing this. Why? Because the calculation of gram per dm cube concentration and mole per dm cube will be very much helpful here. Okay, so I hope before you watch part 5, please make sure you watch part 4. Alright, okay, now so let's start. Okay, I am going to prepare a standard solution. Why teacher saying standard solution? Because I know the concentration. Okay, so I know the concentration 1 mole per dm cube of sodium hydroxide. Okay, so now sodium 23, these are all the atomic mass. Oxygen 16, hydrogen 1. Okay, so now RMM is 40. Okay, so RMM for sodium hydroxide is 40. Now let's go to calculate and weigh. What do they mean by calculate and weigh is, first you find the mole. Okay, using the concept mv over 1000. This is also shown in our part 4 video. Okay, so calculate the mole. mv over 1000. M, this is M molarity, this is V. So the mole is 100 times 1.0 divided with 1000. I hope you understand why you have to divide with 1000. Why? Because the volume is referred in the form of cm cube. Okay, so the answer will be 0.1 mole. So now you get 0.1 mole. Now what you have to do? Now you connect your relative molecular mass alias molar mass with the mole. In order for you to hit 1 mole, The molar mass says you must have 40 gram. But unfortunately, you only have 0.1 mole. 0.1 mole will get you 4 gram. So now you know sodium hydroxide powder, the amount of sodium hydroxide powder that need to be weighed. Okay, you weigh in order to prepare this much of sodium hydroxide standard solution, you have to weigh 4 gram of sodium hydroxide using a dry weighing bottle, and you transfer. Okay, so you weigh, okay, you calculate which you have done, you weigh using a dry weighing bottle, then you transfer the substance in a 25 cm cube worth of water, and you just transfer the substance 4 gram of sodium hydroxide, 4 gram sodium hydroxide that you have calculated to dissolve. Okay, so the main reason we do this is for you to dissolve. You dissolve your sodium hydroxide. Now comes the next step, dissolve. Okay, so you dissolve. First you dissolve using 25 cm cube of water, and you transfer. Okay, so you transfer into 100 cm cube volumetric flask. Okay, so volumetric flask looks like this. Okay, so volumetric flask roughly looks like this, and it has a calibration mark. Okay, so using distilled water, you transfer the 25 cm cube of solution into volumetric flask, but make sure, because you're preparing 100 cm cube of solution, make sure you use the volumetric flask which is equivalent to 100 cm cube. Don't use different 250 or 500. Okay, now so what you do is you fill in water, distilled water, diluting. You fill in the distilled water until it hits the calibration mark. Okay, until it hits the calibration mark, then what happens is transfer. So this is what we call by transfer. So you transfer in a volumetric flask and you fill in this distilled water until it hits the calibration mark. Calibration mark shows you that you have added enough water until it is 100 cm cube. Alright, then you just stop, you just close the, okay, after you have filled in, okay, after you filled in, you just close it with the stopper. Okay, and you just invert it, yeah? So invert it, you just invert it few times. Okay, so invert it few times so that the solution mixes properly. So what have you prepared here? So this is 100 cm cube, 1.0 mole of sodium hydroxide. So in fact, when teacher asks for alkali acid to be prepared, your lab assistant, they prepare in such a way. So we can say that your lab assistants are indeed preparing standard solution. Okay, so teacher repeat. So standard solution is a solution where the concentration is accurately known. Okay, so the concentration of the standard solution is accurately known. Second is we use the concept of part 4. We use the concept of part 4, which is calculation of concentration and also calculation of mv over 1000. Okay, mv over 1000. So in order to prepare 100 cm cube 1.0 mole, this is different from your module. Teacher purposely gave different so that you know the difference in calculation. Okay, so 1.0 mole. So this is m, this is v. Okay, so you find the mole, 0.1 mole, m, using the concept mv over 1000, you get the mole. And you calculate the RMM for the substance that you want to prepare the standard solution of. Okay, so here I'm going to prepare sodium hydroxide. I'm going to prepare sodium hydroxide, and RMM for sodium hydroxide is 40. So you know that in order, RMM Elias molar mass shows that in order for me to hit 1 mole, I must have 40 gram. But here I only need 0.1 mole. After calculated, I know I only need 0.1 mole. So I weigh 4 gram of sodium hydroxide, dilute it or dissolve it in 25 cm cube of water, then transfer it to 100 cm cube of 100 cm cube worth of volumetric flask, the size of volumetric flask. Then I fill in the distilled water until it hits the calibration mark. Okay, when you hit the calibration mark, it shows that you have indeed reached 100 cm cube of solution. Okay, so this is how standard solution is prepared. Now let's go to second subtopic, which is prepare or dilute a solution. What do you mean by dilute? Okay, so as we know that concentration is the amount of solute in the solution. If teacher say more concentrated, this is example of more concentrated. 2.0 mole dm³ is more concentrated than 1.0 mole dm³ of any substance. This is more concentrated than 0.5 mole. Can you see? dm³. So in order for you to concentration, you can see it from the decrease in number. So what happens is sometimes you have a more concentrated substance. So this substance or solution can't be used sometimes in experiments. So teacher have no choice or your lab assistant has no choice but to dilute. Mark by word, dilute. Melarutkan. Okay, so we add more water. That means you're diluting. You're preparing a syrup. You put too much of syrup and it's too thick. The solution is too thick. You can't even drink it. So you might add, can you see, you add some distilled water or water so that the juice will become dilute. So from concentrated, you are diluting it. So one concept I want you to understand, okay, for concentrated, it becomes a dilute solution. Now one thing that you need to understand is in concentrated and diluted solution, the amount of mole is the same. For instance, this is 1.0 mole dm³. This is 0.1 mole dm³. Okay, so just say this is concentrated. 1.0 mole is definitely concentrated. You just have 25 cm³. Okay, 25 cm³. But here just say the amount of solute is, just say teacher draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that 25 cm³, 1.0 mole per dm³, the solution is very concentrated compared to this. Okay, this solution is concentrated. And the amount of particles, just say in here is 10. But here, in order to dilute, remember what I told you, in order for you to dilute, you have to add water. So, when you add water, obviously, okay, the volume is going to increase, maybe to 100 cm³. So, you add, still 25 already intact, so you add another 75 cm³ to make it 100 cm³. But please remember, amount of solute, it's still the same. Okay, 10 dots. Teacher here draw 10 dots, I draw here 10 dots too. So this is the concept I want you to understand. When you are diluting a substance, only volume gets affected, not the amount of solute. Okay, so here you have 10 particles, just say 10 particles. Here will be 10 particles as well. So that concept is the one we are using to, which is N1 equivalent to N2 before and after dilution. This will convert into M1V1 because for molar is equivalent to M2V2. So this is what you need to know. So please remember, when you are calculating diluted, okay, you're calculating how much water you're supposed to add in order to dilute. you must know that the amount of mole is still the same. Alright? Okay, now so let's go to one example of dilution. Okay, now before that, what you have to do, these are the steps, few steps of dilution. First is you have to calculate. What is you have to calculate? You have to calculate the amount of mole involved and also the amount of water you need to add in order to dilute something. Remember just now the diagram I draw just now? So you already have 25 cm cube of water. So in order to make it 100 cm cube, you just added 75 cm cube more. Can you see? So that is what you have to calculate. Okay, so you have to calculate the amount of water that needed to be added in order to dilute it. Second is you will draw. Okay, you will take a bit of solution using a pipette. Okay, using a pipette. Then again transfer it into volumetric flask and add water until the calibration mark. Okay, so please refer to page 115. Okay, now what you do is first you calculate the amount of water. Okay, amount of water to add. Okay, amount of water that you need to add. Then you use a pipette. Okay, you use a pipette to draw 10 cm cube from the original concentrated solution. Okay, from concentrated solution. Okay, transfer into volumetric flask. Then you add water until the calibration mark. That means now you want to prepare 100 cm. For instance, let's look at this example. Now the concentrated solution is 2 mole per dm cube. So please look at here. 2 mole is definitely more concentrated. It has more solute. Okay, concentrated compared to 0.2 mole. But now I want to dilute 2 mole into 0.2 mole, but I only need 100 cm cube. So now the question is, how much water do I need to add in the 2 mole per dm cube solution in order to get this standard solution? Alright, so this is where your M1 V1, M2 V2 comes in. Okay, so M1 V1 equivalent to M2 V2. Okay, now M1 V1 100 times 0.2 is equals to, you don't know the volume. Okay, you don't know the volume. So volume times 2 mole. Okay, dmq. Okay, so just 2 lah, you put 2. Okay, so the volume you are supposed to get is 10 cm, 10 cm cube. Can you see? 10 cm cube. So this 10 cm cube is the one that you will pipette from the concentrated solution. Okay, so you pipette 10 cm cube of the concentrated solution, transfer it into 100 cm cube worth of volumetric flask. So the volumetric flask, the calibration mark is 100 cm cube. Can you understand this? 100 cm cube of volumetric flask. The calibration mark hits 100 cm cube. Why? Because here says we want 100 cm cube. And here it says you only need 10 cm cube to be pipette. You pipette 10 cm cube. So you pipette 10 cm, you just transfer it into this volumetric flask. So after you transfer it into volumetric flask, you just add water until the calibration mark. So what happens is, here after you have added water, you will find that here you have successfully prepared 0.2 mole dm cube of solution. Okay, so now you can see that in order to dilute, definitely you have to add water. That is what you did here. You did add water. So now, since we are dealing with standard solution, which the concentration is known, even dilution, okay, even dilution will be meticulously prepared. Okay, so you have to do calculation properly, then you can dilute the substance. Okay, so I hope you all can understand. told you all in part 5 video. We will continue with our next videos for upcoming subtopics. Thank you for watching and take care.